Hey guys, welcome back everybody. Hope you all are doing great. Guys, today in this video we are going to understand service side configuration of SD-WAN. Means I am going to configure service VPN on VSS and CS through CLI. Till now we have seen the authentication process, like how to install the certificate, how to download the certificate from CA server, and then the onboarding process of all SD-WAN devices. In the last video we had seen the SD-WAN topology, how SD-WAN is working on overlay, about the control connection, IPsec, tunnel between WAN edge devices, and today we are going to see the service side, like I will configure this subnet here, this subnet, and this subnet through CLI. So without wasting our time, let's begin. If you want to verify the previous configuration, you can access your VS. Here I have access of my VS, you can see, and 3 WAN edge devices are online up, right? 4.4.4 is my VS, branch 1 VS, 5.5.5 branch 2 VS, and 6.6.6 is my CS in branch 3, and all the devices are live. Even you can access the VS Smart, you can verify the OMP session on any WAN edge devices, you can verify the control connection, IPsec, BFD, OMP, right? You can verify those all things, but there is no any service VPN configured till now here. If I am going to access, let's say, branch 1 VS1, and if I will log in, it is already logged in, so run. In the running configuration, you can see this is my system wise configuration, the vBond, clock time zone, organization name, the system IP, side ID. After that, here OMP configuration is default. Here is my VPN 0 configuration. In VPN 0, you can see Giga Ethernet 0/0 is added in VPN 0, and the IP address over here, and one default route is there in VPN 0. After that, we have management VPN, VPN 512, and no any other VPN is there, right? So for an example, I am going to use VPN 10 for service VPN, right? For this interface, I am going to create here VPN 10 service VPN. So guys, configuration between VSS and CSS is same, but the command is going to be different. Like here on VS you will create the VPN, and on CS you will create the VRF, right? So let's say here I am creating VPN 10 on VS, so I will create VRF 10 on CS. Let me show you all the things. Let me start configuration from branch 1 VS1. Here I am going to create one service VPN. To create the service VPN, it's very simple, just say VPN and then VPN ID is going to be 10. Then which interface you want to add in this VPN? I want to add interface Giga Ethernet 1. Here I can say no shutdown, and then I can define one IP address over here. IP address is 10.10.1.1/24. You can see /24. You can see here subnet between branch 1 VS, like this VS, and internal router is this one, 10.10.1.0. Here my service side subnet is 10.10.2.0 and 10.10.3.0 over here in branch 3. So I have configured .1 on VS, you can see, and now I am going to commit the configuration. And now we have one service VPN, which is VPN 10. You can verify that, so run VPN 10. And in VPN 10, you can see I have added interface Giga Ethernet 0/1, and this is the IP address there. I am not running any routing protocol. Later I will configure OSPF, because later we are going to understand the template based configuration as well, right? For the detailed configuration, I will create the template on my vManage. Okay, so here service VPN is done. You can check the routing table of VPN 10 as well. So IP route VPN 10. Right, so in the VPN 10, you can see I have only one subnet, which is 10.10.1.0/24, and this is connected network, directly connected. Now let me take you to VS2, branch 2 VS. Let me create VPN 10 here also. Say VPN 10 interface G0/1, say no shutdown, and the IP address is going to be here, sorry, IP address is going to be 10.10.2.1/24. You can see the subnet here, 10.10.2.1/24, and let me commit it. Here also we can verify the service VPN, so run VPN 10 right? So in the service VPN we have correct interface and the IP address is also correct. Now if I will show you the routing table of VPN 10, so IP route VPN 10. So you can see now two networks are there. One is connected network and one is coming from OMP protocol. This is coming through OMP and this is my connected network. 10.10.2.0 is connected and 10.10.1.0 is coming from branch 1. This is the subnet of branch 1. So how it is learning? Through OMP protocol. What is happening over here, guys? By default OMP redistribute connected network. So this is connected network, OMP will redistribute it, and here we have OMP session. You know this. Here we have OMP session, here also we have OMP session. So through OMP branch 1 VS1 is going to advertise this connected network 10.10.1.0/24 to VSmart, and VSmart will advertise it to another peer, another OMP peer, which is branch 2 and the branch 3 also, CSR also. Here also we have OMP session, right? So it will advertise same submit to this CSR also. Let me show you here on the VSmart if you want to verify it. Here let me log in with admin credential and say so OMP peers. So you can see 3 OMP peers are there: 4.4.4, 5.5.5 and 6.6.6, correct? So that's why in the branch 2 WAN edge device I am able to find branch 1 LAN prefix. In branch 2 I am able to find branch 1 prefix. In the branch 1 also you will find branch 2 prefix. Now you can see 2 subnets are there, and this subnet 10.10.2.0, which is the LAN prefix of branch 2, is coming from OMP, and here is the TLOC. TLOC is 5.5.5, color is default and encapsulation is IPsec. This is the TLOC for this subnet, side 1 subnet. Here the OMP TLOC, and here it is connected network over here. So fine, let me do one thing now. Let me show you the CSR router. Let me take you to CSR router. Let me access it. On the CSR router, see, until and unless you will not create VPN 10, you will not find prefixes in VPN 10. So here what I have to do to verify the prefixes, first I have to create the VPN 10, right? Enable and so I show SD-WAN OMP route, let's say for an example. If I will run command like this, you can see no any prefix is coming from OMP protocol. Reason is VPN 10 is not created over here in branch 2, and these two sides, guys, side 1 and side 2 LAN sides can communicate as well from branch 1. If I am going to ping branch 2, let's say ping in VPN 10, and the subnet of branch 2 is 10.10.2.1. So you can see ping is working, right? So LAN subnets of branch 1 and branch 2 are communicating. Ping is working fine. Now let me configure CSR router branch 3. Here I am going to create one VRF, configure transaction. I will create one VRF definition with number 10, VRF definition number 10. Now number should be same, right? This is VPN only. Number should be same. Here you can define the RD value, which is locally significant in SD-WAN, 10:10. And after that I am going to define address family. Here if you want to define address family IPv4 and then exit. And now we need to add the interface in this VPN. Which interface you need to add? This interface, gig 0/2. But before adding that interface, if I am going to show you the OMP routes here, sorry, commit command is required. Yes, commit completed. And now if I will show you the OMP, so SD-WAN and OMP routes. So now I am expecting branch 1 and branch 2 prefixes here. Let me see. So you can see once I have created VRF10 over here, the LAN prefix of branch 1 and the LAN prefix of branch 2, both the prefixes are coming here, right? 10.10.2.0 and 10.10.1.0. 10.10.1.0 is LAN prefix of side 1 branch 1, and 10.10.2.0 is LAN prefix of site 2, and here you can see the TLOC, and from where it is coming from the vSmart. Both prefixes are coming from vSmart only. Both the prefixes are coming from vSmart. You can also check the routing table of VRF10, like I can say show IP route and VRF10. It will show me the routing table of VRF10, and you can see these two subnets are there. These two subnets are coming through OMP. This small m is nothing but the OMP here on CSR router, you can see, right? So it is coming from OMP and reachable via 4.4.4, reachable via 5.5.5. One prefix is reachable via 4.4.4, another subnet is reachable via 5.5.5. Now we need to add the LAN interface in VRF10 over here. LAN interface is my Giga Ethernet 2, you can see. Now to add the interface in this VRF, again I will take you to the config transaction and then go to interface, Giga Ethernet 2, interface, and Giga Ethernet 2, do show IP interface brief. So IP interface brief, let me copy the name of the interface. Sorry, this command even will not work. Do is not working here. Here we can run command show IP interface brief. So see, these are my interfaces, and I want to put this interface in VRF10. So gigabit Ethernet 2 config transaction, and then go to interface gigabit Ethernet 2 interface, Giga Ethernet bit 2 here, enter, and I want to put it in the VRF. What happened? Sorry. Gigabit Ethernet 2, and I want to put this interface in VRF10. You know how to put the interface in VRF10. VRF forwarding number 10, and then say no shutdown, and here let me configure one IP address which is 10.10.3.1.255.255.255.0, and let me commit the configuration. Commit. After the commit, I am expecting this branch 3 LAN submit should be also there in branch 2 and branch 3. Now you can see commit complete. Let me exit from here, exit and exit, and now let me take you to the branch 1 VS, and show OMP, so IP route via VPN 10 for an example. And now you can see in VPN 10 10.10.3.0/24 is also coming, which is branch 3 subnet. And now if I will ping in VPN 10 from to 10.10.3.1, then I am expecting reachability, and you can see there is reachability. All the sites are able to now communicate, are able to like LAN users are able to communicate. Now here we have internal routers, guys, inside the subnet, inside the branches, the internal router, and we need to configure any routing protocol here between WAN edge devices and the internal router. So you can enable that. After that, your LAN prefixes will be also exchanged through OMP. Maybe you need to configure the redistribution, but today in this video we will not discuss that. We'll see that in any another video. Today we have only seen the service side configuration. Even we have not verified it. We'll verify the flow in detail in any another video, because some of my students were requesting me to make a small video. It's easy to learn, so that's why I am just trying to make video up to 30 minutes, right? But sometimes, guys, it's not possible to cover in 20 or 30 minutes. So sometimes definitely video length can be 1 hour, 2 hour, but most video is going to be for 30 minutes only. Okay, so hope it is clear how we have exchanged the LAN prefixes, and you can verify the TLOCs for all the prefixes. Like here on branch 1 VS1, if I am going to show you show IP route VPN 10, because video length is 14 minutes, we can discuss some more thing here. Like you can see 10.10.2.0/24 prefix is coming from OMP, and the TLOC is 5.5.5. Color is default and encapsulation is IPsec. This is TLOC of branch 2 over the internet. TLOC is nothing but the transport locator. You can say unique identity of transport. It is similar like the next hop in the traditional routing. Like if this VS branch 1 VS want to forward traffic to this subnet, they will use this TLOC to forward subnet, right? This is not the next hop, this is TLOC, transport locator. In this TLOC, next hop IP address is there, right? And for you can see 10.10.3.0, again it is coming through OMP, and TLOC is 6.6.6. default color and encapsulation is IPsec. If you will open any TLOC, for an example 6.6.6, you can use command show OMP TLOCs. TLOCs. It will show you the all TLOCs. And here you can see TLOC of 6.6.6. I want to verify the TLOC of 6.6.6, like what is the public IP address and private IP address of this TLOC, right? So guys, see, I am not using any private IP address. I have directly public IP address over here. 101.3.1.1.1, 101.1.1.1, 103.1.1.1 is the IP address of my CS. So here you can check the public IP address and private IP address in this TLOC. Here is the public IP address. You can see 103.1.1.1. So this is the IP address, next hop IP address to forward traffic to this TLOC. But this WAN device have already one IPsec session with this TLOC, right? One IPsec is there, so traffic will go via IPsec. Traffic will go through IPsec. Here you can verify that. So IPsec inbound connection, and you can see for same TLOC 6.6.6 color default and encapsulation IPsec, we have what IPsec. Between 4.4.4 and 6.6.6 we have IPsec over which color? Our default color. Our default color we have IPsec session. Encapsulation is IPsec and system IP, and the color here you can see. So two IPsec sessions are there over here, one with branch 2 VS and one with branch 3 VS. We have one IPsec over here and one IPsec over here, right? So your traffic is going to flow through IPsec. You cannot discover the internet router. Even you can trace route, or even you can verify it from your vManage. Like from my vManage, I can take you over here in the network. In the monitor, go to network section, and in the network select the device branch 1 VS1, and here go to troubleshooting. In the troubleshooting, you can see the trace route is here. Trace route and simulate. You can simulate the traffic. You can trace route the traffic. If I am going to trace route to destination 10.10.3.1 branch 3 LAN interface IP address, in which VPN? In VPN 10, and the source interface 0/1 and IP address 10.10.1.1, right? In the advanced option, here you can define the size. Let me leave it on default and click on start. So you can only discover, see what you can discover over here. You can discover your on VANage device, which is 10.10.10.1, and the another device is 10.10.3.1. This is my CS branch 3 CH. This device IP address here is my 10.10.3.1, this interface IP, and 10.10.1.1 is this interface IP. So directly we are discovering here too. Here we don't know anything about internet router. We don't know about the WAN link, right? Because guys, here we have IPsec. Because we have IPsec and traffic is going via IPsec only. Traffic is going via IPsec only. You can see, right? And how much time it is taking? 49 millisecond, around 49 millisecond. And here is the detailed information. You can see trace route 10.10.1.1 and then 10.10.3.1 in VPN 10, right? Similarly, you can also use simulate option to check the transport. Here I have only single transport, so definitely traffic will go via internet only. VPN 10, here we can define the source, here we can define the source address, here we can define destination 10.10.3.1 1. And application NE for an example, let me click on simulate. You can see traffic is going and coming via internet, right? IPsec. IPsec. This is color. The default is color. Here you can set color now. Biz internet. In the future video, we'll add more transport and we'll verify these all things. We'll see the path manipulation and load balancing as well. Okay, so hope it is clear, guys. In future video, we'll talk more about the packet flow here. Thank you so much for watching this video. If you have any question, query, concern, please let me know in the comment section. Otherwise, I will meet you soon in the next video. Bye bye, guys.